Hi everybody, welcome to Chapter 8. In Chapter 8, we're going to talk all about fractions. The beginning of Chapter 8 has quite a bit of information we need to remind ourselves for the rest of the chapter. First and foremost, a fraction is made up of two parts, the top number and the bottom number. The top number of a fraction is called the numerator. The numerator represents how many parts of a whole thing you are talking about. The bottom number, or I like to say the down number because of the D, is called the denominator. The denominator tells me how many total parts I am talking about. For example, I have a figure drawn here. I have two parts of my whole shaded in. My 2 is represented in the numerator. I have 1, 2, 3, 4 total pieces of my square, which is represented in the denominator. We're going to talk about numerators and denominators for chapters 8, 9, 10, and even further along this year. For section 8-1, we're going to talk about equivalent fractions. Equivalent is a fancy word for equal. Fractions that are exactly equal, but they might be shaped a little bit differently. Let's pretend my square here is a delicious birthday cake. If I have 4 friends showing up, okay, and only 2 of my friends eat the birthday cake, they've eaten 2 pieces out of 4. However, if I have more friends show up that I didn't expect, I can't make a bigger birthday cake. I have to keep my cake the same. But what I can do is cut it into equal pieces so that everybody gets a fair piece. In this case, I'm going to pretend 8 friends showed up. Here's my cake, and instead of having 4 equal pieces, I'm going to turn it into 8 equal pieces. Make a cut there, and we'll make a cut there. You can see I now have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. That's going to be represented by my denominator. My 2 pieces that were eaten have now turned into 1, 2, 3, 4 pieces. So an equivalent fraction for 2/4 would be 4/8. That's how to figure that out using a drawing or a figure. Another way we talked about in class is by doing multiplication or division. What we're going to do here on the bottom, I have 4 problems written. We're going to figure out equivalent fractions for each one. In 2 examples, we're going to use multiplication, which means we're going to go from smaller numbers and find larger numbers. For 2 of the problems, we're going to do division, which means we're going to start with some larger numbers and try to find smaller numbers. Let me show you some examples. For 6/9, I've told you that I want an equivalent fraction that has a numerator of 2. How can I go about figuring this out? I know that since I'm going from a big number to a small number, I can't multiply, because when I multiply, my numbers get larger. So I'm going to divide in this situation. Now I need to figure out a number that's going to work with both my 6 and my 9. Because as we stressed in class, don't forget, what you do to the top number, you need to do the exact same thing to the bottom number. Let's see, 6 divided by what will get me 2? I'm having a difficult time figuring that out. Remember, division is simply multiplication backwards. So I could think of it as 2 times what number will get me to 6? I know that. It's 3. 6 divided by 3 is 2. What I do to the top, I need to do the exact same thing to the bottom. 9 divided by 3 is 3. So an equivalent fraction will be 2/3. In the bottom example here, I start with 2/3 and I'm going to a larger number. Well, I know that when I go from a small number to get a larger number, I'm going to need to multiply. I just don't know by what yet. 2 times what number will get me to a new numerator of 8? 2, 4, 6, 8. 2 times 4. What I do to the top, I need to do the exact same thing to the bottom. So I do my denominator, 3 times 4, and my new denominator becomes 12. So 2/3 and 8/12 are equivalent fractions. Now, I have 2 blank ones. I give you the freedom to do what you want with these numbers. This one is going to be a multiplication problem. This one is going to be a division one. The multiplication, as we discussed, is usually the preferred, easier way. So, in my case, I'm going to pick the number 5. Actually, let me pick 3 for purposes of our example. What I do to the top, I need to do to the bottom. So again, 2 times 3, my new numerator is 6. 3 times 3, my new denominator is 9. Same thing. This shows you how multiplication and division are opposites of one another. 6/9 you can divide to get 2/3. 2/3 you can multiply to get 6/9. And while division may only have 1 or 2 possible answers, multiplication has an infinite amount. I could have done times 9. I could have done times 13. I could have done times 6. And I would always find an equivalent fraction when I am multiplying. Division, though, is a little bit different. For division, I need to find a number that I can divide with both my numerator and my denominator. So in this case, if I chose 2, I could do 10 divided by 2 and come up with 5. However, 2 is not a possible solution. The reason is I can't do 15 divided by 2 and come up with a whole number. Can I do 3? Well, 15 divided by 3 certainly will work, but I don't have anything that will work with the 10. 10 divided by 3 will not get me a whole number. This goes back to the previous chapters we talked about with multiples and factors. What number would be a good factor that would work with both 10 and 15? I said 2 doesn't work, 3 didn't work, I know 4 doesn't work, 5. 5 is absolutely a possible solution. Because I can do 10 divided by 5, I'll get a new numerator of 2, and 15 divided by 5, I'll get a new numerator of 3. So if you take a look, 2/3 and 6/9 are equivalent fractions, but I also got 2/3 as an answer here, which means it's also equal to 10/15. That's absolutely a possibility. So, since these two are equal, 2/3 and 6/9, and 2/3 and 10/15, that must mean that 6/9 and 10/15 are also equivalent fractions. I hope this helped you a little bit to give you a quick overview of how to find equivalent fractions using both multiplication and division, as well as using a figure and cutting that figure into smaller pieces. Remember, the larger the number, the smaller the pieces of the whole fraction are going to be. Thanks for watching, and I'll catch you tomorrow.